YouTube still says starting to. So we are live. So we have Whosa Whatsis, which camera? We have Rastall. We have Brook Drumm apparently joining at the moment. And we have Richard Horne. So welcome guys, 15 years. Let's see where this goes. So, as usual, who wants to start out?
Have we got any topics to chat about?
Well, I was thinking one of the topics that is definitely going to come up is the whole Makerbot patent affair.
Yeah, that's why I got a beer.
Yeah. So there's basically been two polar opinions on Makerbot, or, well, not exactly polar to each other, but there's one camp that's going, Makerbot is shit, they're stealing everything, they are like the worst kind of company. And there's some people that they're starting to say, well, I can see why they're patenting everything and why they're turning into a big business law. And well, personally, I can't see myself there. I've worked at companies that value themselves by the amount of patents they own. And I can see why Makerbot is starting to do that, but it's still an asshat move to invade the communities, to invade into the communities' work and basically actively try to stop that. So I don't know. I was wondering what you guys are thinking about that. Where's your standpoint on that?
Yeah, well, I think it's certainly completely unacceptable for them to be patenting the work of other people in the community without their permission. It's absolutely unexcusable. I have been thinking about it a lot, and it seems like something like what Tesla is doing, where you patent things, but then you grant a license to use those patents, and you won't sue anyone for them. It's kind of like just doing open source through the legal system. And so if they were doing that, I mean, it's a more expensive way, and it's kind of a dangerous way, because if that license can be revoked, like if Stratasys came in and said, no, we're not doing it, we're not handling our patents that way, these are our property, then, or if a smaller company did that and then was acquired, they'd be in danger of that happening. So that's the danger of doing it that way. But something like what Tesla's doing might be better than just open sourcing, because there would be legal protection behind it. I would like to see some kind of copyleft license for patents.
Don't you think that behaviour from Makerbot is being driven by their parents now anyway? That it's you know, it's a behaviour that we've seen with Stratasys for, well, as long as I've been paying attention to it, and I strongly suspect that for all the fact that Makerbot got to sort of behave as they were previously after the initial buyout, then gradually they're getting integrated into the parent, and the corporate behaviours associated to Stratasys will start to leak into Makerbot's behaviours. So it's almost sort of inevitable that they're going to take that kind of approach to things, irrespective of the impact it has on the communities that they used to be kind of heavily involved in. It's sad, but I think it's just the fact of their sort of kind of corporate behaviour now that's going to continue.
Yes, I definitely think that Makerbot, that Stratasys is a big reason behind the surge of patents. But Makerbot was already headed this direction, at least long before we knew about Stratasys acquisition. I don't know how long those talks were going on before that. But I was just thinking, if I were to patent it, what would compel me to do such a thing? And that's the something like what Tesla is doing is the reason that I would do that if I was going to.
Yeah, and they've not responded on any level that sort of indicates that they have any intention of that. So I think it's best to assume that it's purely a land grab thing, and that there's no, you know, if they see it as an opportunity to reduce competition going forwards by litigating against those patents, then they'll do it.
Yeah. I mean, what Tesla is doing, and basically what everybody is suspecting that they're doing, is they are opening up the patents they have right now, and they're saying that they're not going to sue anybody on those. But what they are also going to do, likely, is that they're just not going to apply for any patents at all. Because what they are saying is that the Chinese guys will be copying their work anyways. So they'd rather not put the ideas out there of what they're doing and rather just do things.
Yes.
Force them to reverse engineer instead, yeah?
Yeah, so that's the Tesla thing you're talking about, not Makerbot. But, so it's an interesting situation. They've also already been doing pretty much the same thing with SpaceX, which is also an Elon Musk company. But he said specifically in there that they're not patenting anything because their primary competitors are governments, and governments don't have to apply to patents. So they'd rather just keep things secret, which is not as open as everyone's giving them credit for being with the Tesla deal.
I think it's still a much better cause than actively trying to limit competition with their patents. Yeah.
Yes, and at least when something is a secret, somebody else can come up with the same idea and develop it. Whereas once it's patented, you've got the legal system keeping development from happening for 20 years. I like to say that my personal catchphrase is that every new patent issued extends the dark ages by 20 years.
True.
It's probably even worse than that. I think the amount of patents that are being issued in the 3D printing sector really don't just stop innovation, stop other people coming along, but a lot of these patents are actually not even being acted on at all. So they're very, very much blocking and actively stifling development within the community, if not at a basic level of understanding that there's someone out there that's going ahead and doing a lot of patenting with the intention to use them in the future, or just really to try and stop people from developing similar things just due to worries of infringement, that type of thing. So the thing that was worrying me was whether or not we would actually see the same thing happen, that developers would actually start just being more secretive again and decide not to share and not to put their work out there. So what does everyone think about that even in the open source side of things? What do you think?
I think it'd be preferable to having patents where those inventions, those innovations are actively locked up with legal backing so that other people can't develop them.
Yeah, I mean, the one thing I obviously like about the individuals in RepRap is certainly the fact that a design, even if it's under patent, an idea can be replicated just for yourself or for your own individual uses all over the world by lots of different people. So that causes not so much of an issue for developers that want to get designs that might be close to patents out in the world for people to produce themselves on their own 3D printers, but it does cause a lot more problems, obviously, for companies and smaller companies that are wanting to actually commercialize on ideas and projects. So I think, yeah, we might see more developers decide to keep their work secret rather than disclosing it openly, I think, which is something I've been worrying about and thinking about for quite some time now. So yeah, it just depends. Just depends whether people are going to stay open, or whether they think that ideas will continue to be used and patented even when they're out there in prior art.
Yeah, you might see the opposite too. Open source companies will be more aggressive about publishing their open source so that it can be used as prior art to block patents.
That's certainly the case for us. That's definitely an avenue that we're looking at for certain things that we're playing with at the moment. And aggressive disclosure is something that we're looking at as an option on the table. The other thing that we're looking at is perhaps, I don't want to make any sort of firm comment on this, but is defensive patents with something like a legally binding patent promise in the vein of Red Hat, simply because that gives you better defensibility than a simple prior art claim on something like a blog post or things like that. As much as we'd like to think it does, simple prior art doesn't carry the same legal weight as at least something like a pending patent or something like that. So it's a tricky line to walk.
Yes, one way or another, we need to, as a community, figure out what it takes to create rock-solid prior art.
Yeah, absolutely.
And start doing it.
Whether that's a patent pool or whether that's some guidelines for disclosing prior art. Like in the olden days, back on some of the RepRap developers blog, there was certain efforts to create a way of people formalizing prior art on the blog post and saying, I'm disclosing this for the purposes of prior art. But if we get a sort of maybe a legally advised, slightly more enforceable, not enforceable, that's the wrong word really, but something that takes advice from someone who has knowledge in that field, which certainly isn't me, in a way of disclosing something that makes it decent, defensible prior art. And if we can all adopt a strategy for creating defensible prior art, I think that would be a really good move.
So how well tested is that? Is it understood that there's a certain level of prior art you can get to the extent where you can, with confidence, release your stuff, or is it still something that needs to be tested and cleared?
Sorry, I didn't quite catch that, Tim.
Sorry, mate, I've got a sore throat. So is that something that you is that something that there's already an understanding of the level of rigor and sort of thoroughness you have to apply in order to get across that sort of line? Do you see what I mean? Like, is it sort of well understood that there is a level of prior art and sort of a legal course you can take to ensure that you don't find yourself in a competitive patent situation later on? Or is it still something that's being discovered?
Honestly, I don't know where the line sits as to where something becomes decent and what factors add up to making it decent prior art. I don't know if someone else can chime in. But what I do know is a very, very solid way of doing that, if not a very expensive and convoluted way, is to actually apply for a patent on those ideas. Whether you get it granted or not is another matter. So the act of applying to the patent office makes it a very strong case for prior art, because you have to go through their evidentiary and sort of other requirements. So that's not really something, that's not a very accessible route for disclosing prior art.
So it's also
and it
quite
also
difficult.
depends on the country.
Yeah, absolutely.
Yeah.
It's quite difficult for a group as well. I think if you're talking about your own individual company, then that's one thing, and I still believe really that patents, even for small companies, medium-sized companies, are really quite a tricky thing to enforce, because you really need multi-million-pound idea or multi-million-dollar idea for a patent to be worthwhile achieving if you plan to defend it yourselves. So I think that's probably one of the biggest problems with patents and smaller companies and individuals, that you really have no chance of defending something like that anyway. So I don't think the ways for communities or smaller companies to actually acquire patents, the prior art thing is fine, but again, you need someone to be able to push that through and prove that it's prior art. And I think our efforts at the moment, trying to adopt ways to show that things have already been developed that are now being patented or patent pending, is not being particularly successful. However they will, we'll wait to see. But at the moment, there's no real way to do that, and it also takes an enormous amount of time and effort for anyone or any individual to do. So the whole idea of staying open source and not going down this patent and defending and battling thing is really conflicts with the whole idea of trying to keep things moving and doing this for the love of it, really, rather than having to battle all the time. So it's going to be interesting to see where it goes, but it's certainly quite exhausting, and it probably will carry on to be for anyone that actually wants to try and defend something, either their work or someone else's work or a whole community's work. So that's the thing that I guess concerns me. My only other thought, really, I've wondered for a long time, was whether it needed a type of foundation, a bit like the Apache Foundation that is set up for software, that can actually have a little bit more coordination. I guess the one thing we don't have is any sort of directional coordination, really. Whether we need that or not is up for debate, but certainly on the legal side, may be useful.
Yeah, foundation is something I very much want to partake in or pursue. Sort of something along the lines of a patent pool.
Anything that has the word patent in, yeah, I don't think it's going to do very much for us, to be honest.
Yeah, I agree. And we've got this sort of awful situation where essentially our purposes don't fit with the current legal process, and we're trying to shoehorn things like community and open source and sensible disclosure and sharing of ideas into a system that's designed to protect and essentially prevent and monopolize ideas. I don't have an answer for that, but I'm willing to take the sort of actions that need to be taken to try and do what's possible to get this sorted. I don't have an answer. It's a rubbish situation, and I don't like it. And I really hate having sort of almost, I feel like my hand is being forced into doing things like applying for patents for certain things and ideas I'm thinking of. And I really don't want to go down that route, and that I'm kind of then validating that system, which I view as flawed, by making that. So yeah, sorry, rant over. Awful timing.
I guess we're all pretty much agreeing that what we have now isn't what we want. Yeah. There have been questions on the live stream, and people have been asking us to introduce us a bit, because they don't know who we are. They don't know from what perspective we're talking about. So let's just do that for a second. So Sanjay, you're still on the video. Who are you?
So maybe we should start with Rich on the left and
Sure.
on the right, would they?
Okay, you start with me.
There. Okay.
Everyone knows who he is.
Yeah, I guess yeah, I've been doing 3D printing for about 4 or 5 years now, and got started in the early days of RepRap and did quite a lot of things based on mixing colors and doing some color printing, early on color printing stuff, and just generally getting involved with all sorts of things in the community, really. So yeah, if you don't know who I am, go and have a look at my blog. I think it's probably the easiest way. It'll keep you going for a few months at least.
Sanjay.
Yeah, so I suppose my job is I help people push molten plastic through very small holes. So I accidentally started this company called E3D, which you might have heard of. We do hot ends, which are the part of a 3D printer that melts the plastic and pushes it out of a very small hole. I suppose my kind of passion and what we do at E3D is the kind of a high-end engineering and precision manufacturing of parts that enable people to do what I like to think of as real end-user engineering applications for 3D printing. So hopefully moving 3D printing out of the printing of trinkets and sort of ornamental objects, and hopefully getting people printing the useful things, the valuable things, and the things that solve problems in their lives. And the kind of the small part I hope to contribute to the whole 3D printing community is the ability to print real solid engineering materials. So yeah, that's me, Sanjay Mortimer, running 3D online, do hot ends.
Thomas.
Anyway, I'm basically a regular guy of all. I'm just a guy that's 3D printing. I've been doing it for years. The original, and it never let me go. And recently, in videos and very way of giving back to the community. Yeah. That's
I'm not managing to catch Tom at the moment. Is there
No, no, it's just breaking up.
Bandwidth issue there.
Yeah, you might have to turn off your video for us to hear your audio.
Yeah,
Not sure the bandwidth.
I'm going to go first. Okay.
You might have to type, Thomas. I don't think we heard that either. Did you say Rich should go next?
Tim, I think you're up next.
Okay. Hi there. My name is Tim. I am certainly probably the least aged in experience, if not from the point of view of age in this group. I've been sort of playing around with 3D printers for a couple of years now, but I sort of fell into an obsession hole about the whole thing, which has meant that I've been sort of constantly climbing up a very steep learning curve. I am quite active in the G+ community. I'm a moderator on that, and I ended up designing a printer over the last year called the Ingentis, which is got quite a few people building it or variants of it now, and I do a bit of work with E3D as well. Sanjay and Josh and I have a little sub-project going on at the moment we might speak about, although we haven't talked about that yet, so I don't know whether or not we should. I guess we can decide that in a minute. But apart from that, that's it. So, who's up?
Okay, I guess it's my turn. Yeah, I'm Rich Cameron, better known as Whosa Whatsis. I've been doing 3D printing for about 4 years, and lots happened in that time. I designed the RepRap Wallace and the original version of the extruder mechanism that most of the 3D printers on the market are now using. I think when Make Magazine did their review, I think the majority of them are using variants of that design now. So that's good. I love to see the designs propagate and change like that. So I currently work at Maker. I do research and development, and very active on the Google Plus as well. And just developing stuff all the time.
Thomas, you can have another go. You're on mute.
I'll just try again without a video.
I go in the light and go straight.
Okay, I guess I need to mute Brook again. Okay, so who am I? Again, like most of you people, I've been doing 3D printing for 4 years, just about. Started out with the original stealth medal and worked my way up from there. And recently, I've been active on the Google Plus community. I mean, that's where we guys met. And been starting to do 3D printing videos on YouTube, guides and reviews and all kinds of stuff. And yeah, I guess that's just my way of giving back to the community that helped me get going and infected me with this glorious virus of 3D printing.
Cool.
Well, I see that Brook is now back in session. So
Yeah, I'm finally here. Can y'all hear me? Is this working?
Yeah. Absolutely.
Yeah, sounds good.
Okay. So yeah, I'm Brook, PrinterBot. So I actually came in about the same time. It sounds like it's some of you guys, but a little later than others. So it was 2010. Built a Makerbot, and then went straight to the Mendel, Prusa Mendel, and then just tried to improve it. So designed the PrinterBot and did a Kickstarter, and boom. So I've been really, really interested in what's going on in the really hardcore RepRap world, but it is kind of an interesting. Maybe Rich could speak to this. It's interesting trying to be pro. Open source and at the same time run a company, and I've stepped over the line and pulled back and gone back and forth and kind of learned what works. I got to credit Phil Terone for kind of giving me some advice on some of this stuff recently. We're going to move as much as we can to drop the non-commercial is basically what my intention is to do on some of the open source stuff, to be a little more friendly. But it's an interesting line to walk when you're running a business, but I'm open to any feedback on how to walk that line. But anyway, it's good to be here and listening to you guys. I appreciate the time.
I suppose that's everyone. Tim was mentioning earlier about just a little concept that we've been playing with, and I suppose that's kind of something that we'd like to talk about, because it's not really that confidential, I suppose. It's a spin-off of some previous ideas that have been had. So yeah, I don't know, Tim, do you want to kind of take it away? I'm kind of sad Josh isn't here to introduce it. It's a brainchild, I suppose, but yeah.
Yeah, sure. Okay, yeah, so Josh and I have been talking a little bit about building a robot or designing one, which I had a few ideas which were sort of learnings from the the process I went through building the Agentis, which was basically just a really big Tantalus, which in itself was a variation of the Ultimaker. And there's a few things that sort of came out around that caused me to start thinking about new designs, and one of that was scalability. And one of the problems with all of the sort of Ultimaker form factor designs was that they don't scale very well because they rely on a very straight linear shaft that supports the gantry, and the longer you make those, the harder it is to get straight ones, and the thicker they need to be and the more expensive they become. And it has a knock-on effect on all the other mechanics because the bearings have to be bigger and so on and so forth. So we started playing around with that idea, and then Josh just out of the blue came up with this crazy idea that he referred to as CoreXE. What that basically was having sort of a hybrid mechanical system for the XY and Extruder drive, to the extent where you had a drive mechanism, a standalone drive mechanism for the, in this case, the X-axis, and then a combined, there we go, and then a combined mechanism for the Extruder and Y-axis using a single belt and two motors. It's kind of hard to describe, but if you think about a CoreXY or HBot, where you've got a couple of motors controlling the X and Y movements, if you instead use one of those motors to drive a bearing mounted on the carriage by rotating in a this is where the mass cut kicks in. Sanjay, do you want to just talk a little bit about how the combined motor actions enact sort of work?
So, Tom, if you could push those links over to the YouTube thread, that would be really helpful. But essentially, the concept now, you're going to have to be familiar with HBot kinematics to really understand the kind of root of this. But essentially, you have a single belt that contributes to sort of key quanta of motion to your bot. The way that works is you have two motors at the bottom, and then a H-shaped belt loop, and that belt loop, as you turn the two motors either in the same direction or in opposite directions, will maintain one static while you rotate the other, because you have to remember that stepper motors have both holding torque as well as torque in other direction. We can cause carriage, in this case, we call it the XE concept, to either move in X whilst extruding, or move in X while not extruding. This is all a bit useless in chitter chatter, but hopefully we can get some pictures up for you guys to see how that might work as a more knowledgeable amongst you might be able to kind of derive how that functions in terms of the HBot, which uses the motion of the belt to, instead of control an axis, control an extruder. The advantages are essentially getting the low mass carriage of a Bowden extruder while maintaining the precision extrusion of a direct drive extrusion. That's basic aims. There are a whole bunch of challenges. Tim's cracking out with the CAD on there, drawing Rhino.
And our inventor, but I've just got Rhino up at the moment. I'm attempting to get screen share working.
So how are you going to drive a Kraken then with 4 heads?
With great difficulty.
Yeah.
So yeah, I do have a couple of other crazy concepts for doing that without Bowden extruders. Gosh. So
you're mainly just trying to reduce the mass. Is that really what this is for?
Yeah. The way I see it is that we've got kind of two conflicting interests as we go forward in 3D printing. We want to be able to print more materials and more different materials in a single print, but we also want to be able to do that faster and with greater precision. And with current paradigms, none of those concepts are compatible, really. Either you go for a slow machine that has multiple motors and extruders on it, or you go for, and you keep your high precision, or you go for multiple Bowden systems with something like a Kraken attached to something like an Ingentis, but then you lose some precision of extrusion. And I can go on and on. But we have these kind of conflicting interests, and if there's certain ways that we can work towards having both precision, speed, and accuracy in both your motion and your extrusion, that can only be a good thing. This obviously has introduced the whole pile of application, and it's a bit of a crazy idea, but I think it's kind of, if we want to move on, we have to look at these kinds of options.
Yeah, and it is just a crazy idea at the moment, because it's only exists in the digital realm at this stage, although I think Josh is going to try and prototype it pretty soon. Can anyone see the screen share that I've popped up? I have a feeling that I screwed something up in the process of it. I can see it on my screen. But
Yeah, I can see it.
Yeah.
Okay, cool. So, sweet. Let's see if I can actually. I need to. I can't manipulate it there. I need to manipulate it here. So, if you get, I know it'll be a bit laggy, but I'll just stick this on shaded view. So, fairly, mechanically it's not too different from a HBot. You'll see that there's two NEMAs here and here on either side of a carriage. Now, for some reason, just in the process of doing this, I managed to delete the two 8mm shafts that cross between these two carriages here. But it's really hard to explain without sitting down and doing the maths on it. But effectively, by changing the way in which these two motors drive, you can control the movement of the bearing on the carriage to the extent where you can drive an extruder hob gear, obviously using a gearing mechanism that rotates it through 90 degrees. So Josh has done the maths on this twice now, and he seems pretty comfortable that it's going to work. Obviously, in this case, we can only control the Y movement of the carriage using these two motors, and the third one is using a separate motor, which is on here. Sorry, I'm being attacked by a child. So yeah, it's really hard to explain without going into some detail on it. I hope people are getting the gist of it. We will release some files, I think, now we've sort of put this out in the public domain now, so that people can have a look at it. The carriages are running on vSlot, and that's probably all I've got to say, given that I've just been accosted by a toddler. Sanjay, do you want to say anything else about it?
Yeah, I mean, it is just like Tim says, it's merely a concept. We've got some bits of aluminium extrusion.
It's little.
Then turn into actual stuff and move around. But we'll post some sort of simplified diagrams of the kinematics of how the belt path runs and how you turn motor 1 while not turning motor 2, and that results in motion of this and not motion of that, and so on and so forth. If you understand a HBot, you're probably getting everything I'm saying. If you don't understand a HBot, then this is probably all sounds like that. But it's a cool system, and I think that at least someone will get somewhere out of it.
Not me.
Slightly ridiculous idea, and now we're struggling to implement it simply due to time constraints. So it'd be good to get it out there and get people playing with it.
So Sanjay, what's your aim with this then? A bit of a direct question. Are you planning on selling machines?
No, it was just me and Josh and 3 bottles of wine a late evening, and that it is what it is. At the moment, we're E3D. It would be a big step out of our current business model for us to go and create a printer, especially a printer like that. And we've got a clear roadmap of what we want to do, and we've already got prototypes and stuff like that in terms of progression, and it suits our expertise to go in the kind of roadmap where we want to take. So it's an offshoot, and I think it's just an offshoot that we're going to throw into the public domain and hopefully see what they're going to do with it. I don't see us selling an entire machine or supporting an entire machine. But hopefully we'll be able to do some sort of backing for an open source project that will encourage that kind of kinematics, just because I think it's cool. Yeah, that's a very undefined answer, but that's kind of our thoughts on the matter are very undefined, so it is what it is.
It's good.
Cool. Hey, look, I've got to dash off, but I just posted something on the feed. I don't know if anyone had a chance to open it. It's a video that some guys who are working on TinyG shared on the Ingentis Builders Forum. Can anyone see that?
Yeah, I'm observing that now.
Have a throw it up on the YouTube. So this is a sort of plotter variant of the Euthanasios or something like that, which is kind of a belted version of Ingentis. This guy called Jason has designed, and they're running it with TinyG. And according to the feed, the top speed they're heading there is about 833 millimeters a second with the TinyG. So yeah, if you have a look at the video, you'll see it's going like a grease weasel. But I thought it would be interesting to talk a little bit about the implications of the new electronics that are starting to appear and how that's going to change things.
I spent some time with what's the guy's name that did TinyG?
Oh, Riley and Jason are the two people I know, but there's a few of them, I think.
Yeah, the guy that's writing the firmware, man, is he smart. He was talking to me at length about his plans for that. Has anybody run the extruder and everything on a TinyG? Right now, all I've seen is just the motion.
According to Riley, yeah, they are, but they haven't released any videos of it or anything. It's still, on the sound of it, they're probably still going through that bug fixing phase, so they probably don't want to stick it out in the wild until they've got a bit more confident about it.
Yeah, okay. Yeah, I would love to run a printer on. It's just so fast. It's amazing.
Yeah, Rob really knows his stuff. Yeah, my old Makerbot's running on his firmware. I'm pretty sure it's the best printing cupcake in the world.
I bet, man. Yeah, he was talking about doing. He called it an abstraction layer. I'm not a programmer, so forgive me, but he's working with encoders and closed loop. Is anybody else toying around with closed loop encoders and motors?
Yeah, I've been thinking about it a lot. I haven't gotten parts into experiment much, but I had some good long talks with him about it while we were there, and I think we both got some great ideas out of it.
I noticed that the Mod T, that crazy Kickstarter thing, is using they're using DC motors and encoders and a servo board. I think it's off of a printer board, but it's off something where they're getting step and direction. So I wonder if there's firmware out there that's doing this, or there's just something that they wrote.
Probably something they wrote. I mean, the new version Makerbot I can't remember. I'm sure Whosa will remember this. Did we establish whether or not there was a DC motor driving that new extruder on the Makerbots with an encoder, or did they just have an encoder as a sort of secondary support mechanism for a NEMA?
I think somebody in Makerbot confirmed that it was a stepper still.
So they just had the encoder there as a protection for running out filament and so on.
Yes.
Yeah, it is very interesting. It's something we've been looking at really seriously. So there are a bunch of options that we've seen. They're all open source options. So there's something called the I think they're called 01 Engineering Super Modified Servo. I'll just post a link up to that. So you've got the whole modified servo, which is really, really impressive looking, but seems to have been an abandoned project as opposed to
Bye. Bye.
Seems to be there's a lot of work in the RC groups at the moment using rewound BLDC for brushless gimbals, and they're using PID loops, and they're basing those off of data from accelerometers and gyros to stabilize their cameras. But they've got a lot of really quite cheap boards with powerful motor drivers, with good motor driving chips on them and an Arduino on the top that are designed for essentially micro-stepping BLDC motors with a good level of precision and a PID loop in them. There's no reason that those boards can't be then taken and then forced to accept a step and direction signal and keep a position count of where they're supposed to be pointing at. I think brushless motors and DC motors are quite promising in the short term. The reason why I'm interested in them is because there's the potential for getting something quite useful in a very low weight package compared to a large stepper motor. And there are a whole bunch of challenges to overcome in terms of momentum and the fact that you need to spin them up like an but I do think that closed loop is really, really very promising, and certainly in the short term on actually putting closed loop on the carriage. If you forget about the axes for the moment, it offers some certain weight benefits.
Yeah, so a brushless motor is essentially a stepper that's very low resolution. It's the same kind of driving going on. So it's interesting that they're rewinding them. I hadn't heard that. But it seems like they'd get more benefit just using a stepper, except for the fact that the brushless motors are designed to be low weight because they're designed for use on RC planes and helicopters and stuff, whereas a stepper is not. But yeah, that's interesting. It must be micro-stepping them a lot because they're only a couple of steps per revolution, I think.
Yeah,
cool.
I mean,
Well, I think they have to gear them, don't they? I mean, you'd have to have some sort of a gear train if you're going to have any kind of torque.
yeah, so they're not gearing them. Obviously, for an extruder, you would seek to gear them, but they are running them completely ungeared with the shaft of the motor directly attached to your GoPro or whatever camera it is. And they're not from what I've seen in the code, they're not micro-stepping them per se in terms of they have quanta of position, rather than they have their BLDC seeking a set point with a tightly tuned PID loop. So
Analog voltage.
Stepping them, analog resolution. Obviously, they have the quanta of the accelerometer, which is feeding the digital information. But essentially, they are hunting using tightly tuned PID loop set points, which is potentially very useful.
Yeah. And I think you started to mention the idea of using essentially a Bowden extruder with the encoder on the carriage, which would basically take the spring action of the Bowden out of the equation and give you just as much control as having the motor where the encoder is. Something I've been wanting to look into. That's a big reason that I wanted to try the servo stuff.
So here's a crazy idea that I had the other day. So let's say you take a Bowden extruder and you use something, maybe a DC motor, to apply force to that filament. So it's being forced into the nozzle with a constant force of whatever many newtons. But standing in its way is a hob that's located right above the hot end, and that hob has a worm gear on it. And because the worm gear is self-locking, the filament can't now pass beyond the hob unless the worm of the worm gear arrangement is rotated. But because the filament is pre-tensioned, you don't need to really apply the force to the filament with your worm. You merely need to allow it to slip on past. You just need to allow it to pass on by. So you can have a very, very small stepper motor turning your little worm gear on your carriage, but your actual torque, your force, is being applied by a big gun DC motor operator, you're effectively decoupling the concepts of precision and torque in your system. So you don't need one motor that applies all of the torque and does the precision in one hit. You can have a small motor, a very small stepper motor, attached to a worm gear that provides all your precision, and then a large, something like a DC motor, which obviously has issues of burning out and static current and all the rest of it, applying your force to a Bowden extruder. Again, nothing that I've actually practically implemented, just a nutty idea.
Yeah, I've thought about similar things, not with a constant force. That's an interesting idea. I have thought about having two stepper motors, one very light, very low torque one on the carriage, and another larger one that really applies the force on the other end of the Bowden, and stepping them together so that the one on the carriage provides control where the other one provides torque. With the constant force idea, I think you have problems with retraction.
Yes, yeah, absolutely, completely agree. I came to the same kind of idea as you with having two motors, one applying the force and one applying the precision. It was just that the standout part of how that jumped on from there was if you use the worm gear as a self-locking system, it doesn't allow the filament to, because then it stops one motor having to fight the other, essentially, which you would have if you just serially coupled those two. Whereas with a worm drive system, it's kind of self-locking to an extent, and your small motor would simply be allowing it to pass by. But like you say, retraction then becomes a huge issue. I don't have a solution for that, but I think it's an interesting concept nonetheless.
Yeah, it's an interesting idea to use something like a DC motor, something that's just going to provide force, not any precision, when you've got that other motor providing torque. And you could reverse your DC motor when you want to reverse your control motor so that you can retract.
Right,
The reason we wanted to use the encoder.
Sorry, carry on, Brooke. I'm interested.
Oh, I was just going to say the reason that we were Extruder, I ordered a bunch of little itty bitty motors with gear trains and worm drive with very little mass for the extruder, just doing it the conventional way, retraction and all. But it would need an encoder because there's a lot of slop in it, you
know. Just to answer, I see a question on the sidebar that I've just seen. So, Anteresia, polycarbonate. Yeah, it's a real tricky one. But oddly, the best surface I've printed polycarbonate onto that's really easy to achieve is just plain old UHU stick at 120 degrees C. UHU stick it's amazing. Everything sticks to it, apart from POM. But other than that, pretty much everything sticks to it. So if you want a nice, easy go-to, UHU stick works really well. If you really need to get serious, you're going to need to get your bed hotter, somewhere around the 140 mark, is the hottest I managed to get it. And then get some dichloromethane, or what else they call it in America, they call it methylene chloride, which is effectively a solvent that's used for solvent welding polycarbonate. And you can create the equivalent to ABS juice, but polycarbonate juice with methylene chloride or dichloromethane, or even I used trichloromethane once upon a time. They're all really nasty chemicals, so wear gloves, do your appropriate health and safety. But you can dissolve your polycarbonate in this solvent and then use it like ABS juice at very high temperature to get really, really good bed adhesion. Also, good cement for joining a large part together. So, yeah, that's how I print polycarbonate.
I use the lightly oiled sheet of polycarbonate as well. That works.
Yeah, that's a cool idea.
I've heard about people using hairspray on polycarbonate to reduce the stick, make it non-permanent as well. The other thing that you can do, I've been experimenting with this Protopasta polycarbonate ABS blend, which I'm getting some really nice results with. I've also been experimenting at the same time with a new technique of diagonal printing. You place things on a diagonal and print a lot of support, but it's surprising. I posted some pictures just as we were starting of what I'm getting with this. It's really interesting because you don't have any top surfaces or bottom surfaces, so it's more consistent, and it makes it look so smooth.
Yeah,
Is that just?
those are nice prints. I saw some of the pictures you posted. No, I was just saying those were nice prints. I saw some of his pictures. Really cool. I haven't tried it yet, though.
Yeah, it is very nice stuff. It prints very, very nicely, as do all three of their materials, in fact. Justin Cram, the guy who kind of does, from what I can see, does the development over at Protopasta, they're just a really good bunch of guys, and every piece of filament that they send out has a data sheet sample to it with, testing information. They say exactly which NatureWorks PLA resin they're using. They're using the correct ABS resins. They're using Sabic MG94 as their ABS with some Macron going in. They're just doing things in a very open and also correct way. I just think they're cool, and they're onto a bit of a winner, personally. On that note, I think I'm going to have to go, guys, because it is my mother's birthday, and I'm sitting up here chatting RepRap instead of downstairs drinking wine with her. So I'm going to be in trouble when I go back. But it's been great talking to you guys. Josh apologizes for not being here. He's also over at some dinner party, in the real world and stuff like that, which is very unfortunate. But hopefully we can kind of repeat this again, because I've got some really cool bits I'd like to talk about on color mixing and color switching, which is, yeah, it's really exciting. I'm happy with it, how it's going. So talk to you guys very soon. Got to go. I'm going to be in trouble. Bye.
Good to hear you all you guys. Thanks for the time.
I've got a quick question for you, Brooke.
Yeah, shoot.
So you were saying on Twitter the other day about some new ideas or what you guys are thinking about doing next, and it just got me thinking about how you are set up. And do you do all of your development internally now, or are you actively engaging with others in the community to help you out with new projects, new ideas, new printers, that sort of thing?
Whoop, sorry. By the way, if I dump out, it's my battery. Knew this was going to happen anyway. So me and Brian Rowe are the two guys that do the designs. I'm obviously there all the time, so I do a lot of designing stuff. But Brian will come in like 3 days a week, and he's a proper mechanical engineer. That might turn off my mic. I don't know. Can you still hear me?
Yeah.
Oh, okay, cool. So we do it all in-house. I mean, we don't. It's not that I don't want to accept anything from the community, but to be honest, there's not been a lot that I've been able to incorporate. Like there's a big debate on Google Plus about my use of the extruder and who deserved attribution and all that. That's probably the best example of we moved from wood, the kind of a wooden wades that I was doing, over to that idler kind of, the aluminum extruder that we have now. That was the biggest change that I've made from the original designs that I've done. So I don't know. I'm wandering now. I don't know if that answers your questions, but I'm very interested in the open source stuff, and I like the idea of working on some of these bigger printers and just giving all the plans away. They're not really commercial. Printerbot has kind of gone to the value side of the market, so I don't really plan to have any big line of printers. So it's really that's the fun stuff for me. So I've been building some bigger ones just for fun. I'll do a custom job for somebody if they want something. I'm working on one now for Cosmo, that guy that does all the, you know, the scanning of the sculptures. He needs a big one.
Oh, yeah.
Why do you ask? I'm just curious.
No, I was just wondering. It was mainly you had quite a long list of things you were looking at, like laser cutters and all sorts of different things, and yeah, it just got me wondering how you guys were set up and what sort of things are likely to come out of Printerbot, but also whether or not there was a way of communities helping get projects either to market or just in people's hands, really. And the other comment was, I think, one you made on G+ the other day about RepRap becoming non-existent, or I can't remember exactly how you phrased it. But
I said it appears to be imploding, and probably too strong of language. I guess it's less at the forefront is what I meant. You know, when I first started, what was it, 3 or 4 years ago, the folks on the you know, it was IRC, I guess. Man, they were super, super, super opinionated, and I mentioned, like, I'm going to start a company selling kits, you know, and it was like, wow, they were not interested in talking to me. Joseph, Prussia, you know, the whole lot were not excited about any companies coming about. As all these companies have sprung up, and more kind of less knowledgeable of RepRap, folks that are less knowledgeable come in and buy. I think it's just kind of watering down the voice of the RepRap culture. So you got to know where to look to kind of hear and see what's going on. So it just seems like it's a smaller and smaller impact on the market. They brought us so far. I mean, I'm totally standing on the shoulders of giants, right? They brought us so far along, and then it kind of, I don't know if stalled is a fair word, but you know what I'm saying? I don't want to see it die.
Yeah, it's always good to get a different point of view, I guess, because I'm quite close to it, so I see the other side of it. So I see the very active side and lots of things that don't necessarily always lead to commercial products or commercial successes, or even things that people might want to make more than one of. But
yeah, that's a good point. I will admit that I'm a completely biased voice because I'm drowning in, you know, building my own business. It's like so hectic, completely overwhelming, and I probably have less of an ear to it, less than I should. But again, my just so you understand, my heart is really, I would love to see Adrian's dream, you know, come about for the world to have these printers that just reproduce themselves, and it wouldn't have to be a commercial entity. I've always said it's not about the printers, it's about what people do with them. I really do believe that. I get more excited about the things that become possible because of them than the designs of the machines themselves, you know? Because they're kind of good enough. I mean, it's so practical. It's like they're good enough to do some really cool stuff right now. Not that we should stop developing so they can do more. That's where the RepRap really shines today. You guys talking about all these crazy designs is awesome. It'll be a while before those find their ways into the homes of people, I think. But I'm sure glad that the RepRap culture is there developing, that's for sure.
Yeah, and the idea of RepRap has always been that the machines create themselves, but a lot of people have realized that the printers are another term of graphic prototyper. They're great for prototyping. They're great for making things in small quantities. They're not the best technology for making large numbers of things, and unfortunately, the goal of having everyone print one and pass it on, or print two and pass it on to other people, so that it grows, never really materialized. Early on, there was too much hassle getting a printer running reliably enough to make another set of printer parts, and now that people aren't getting RepRap printers, the reliability has increased both within RepRap and without, but a lot of people are seeing it more as something they buy than something that they participate in.
Yeah,
so,
I was discouraged to hear Joseph. He was on Twitter, this long rant, Joseph Prisha, about how, well, I'm tired of seeing all these companies and Kickstarters spring up and take money from the stuff that me and others developed. And if you know Joseph, he's hilarious. He stirs it up sometimes. But he literally said, maybe I should just build a commercial printer out of metal and go about it that way, because it's just, I don't know if he didn't feel it was fair or whatever, but when some of the core RepRap guys are saying stuff like that, I don't know that there's anybody else saying that, by the way, but he did. I was like, wow, is that dream dead? That's a shame.
Well, it's not for all of us. I think there's a lot of people that are quite happy to stick with the RepRap concept and still produce machines that are more and more printable, parts that are more and more printable, and extruders that are more and more printable, more and more replicatable. But I can certainly understand a lot of companies going down. I mean, for me, laser cutting parts is one step that I'm sort of okay with, but when it starts getting to bent metal and mass production, injection molding and things like that, it sort of moves away from the thing I'm interested in. I can understand what people do, and especially to make companies and to sell printers, and especially cheap printers. If you want to do cheap printers, you really don't have much choice, so that's fine, and that meets a market that's looking for that. But yeah, I think Joseph was certainly looking at his i4 being a metal, probably folded metal type of design, and that for me was I was very surprised. I said the same on Twitter and asked him some questions about that. So yeah, I think it will get some interesting reactions, those types of things, but I guess you can only stick to what you believe and carry on in the way you want to do it. So, for me, it's fairly straightforward because I don't have a 3D printing company, so I can do stuff and stick with that philosophy, and I can't see myself, changing from that idea. But yeah,
I certainly wouldn't discredit anyone for whatever road they're taking. I'm not trying to discredit any of those ideas, but I was just surprised to hear this about it sounds like you're doing mostly printable. Do you have a laser cutter?
No.
Okay,
You'll be amazed how little I have.
Well, so what is I know that gosh, I'm forgetting all the names. The Huxley, I guess, is pretty small.
Yeah.
But have you kind of got an opinion about what the size of a RepRap should be if you were able to just continue? Because I've got some designs that I drug up because I love that idea of a fully printable bot, and I was going to try to find some time this next week and work on them. And they're all small, just to kind of proof of concept, but they're like completely printable. No belts, no string instead of belts, no bars even. CoreXE with like a scissor lift Z. But what is the biggest or smallest? Smallest useful size, do you think?
I think. I've been working on small printers for about 6 months. I've got a tiny 3DR Nano that I will release at some point. I just haven't got around to it yet. But and various other very small machines. I'm really quite fascinated with how small you can go, and how light and agile everything becomes when you start scaling things down. So I don't think there is a minimum limit. I think it just depends on the size, what you're trying to do with it. So you might end up with very fine nozzles,
So how
very
big is
slow
your
print
small one?
speeds.
Oh, sorry.
It's the actual print. Yeah, no, the print area is not a lot smaller than the 3DR. It's about 160 millimeters round, so it's actually quite large still. But the physical size of the machine is tiny. It's only 300 millimeters tall. It's a Delta, so it's quite compact, and it's got only 3 main printable parts, and everything hangs off of it. So it's quite neat, but. And on the other side, the Mega is, I'm staring at it in front of me now, the Mega is 1.9 meters tall and is quite a monster. So, yeah, I'm fascinated by the small and the very big. Yeah. So, yeah, it's interesting. I mean, that's completely 3D printed, but that's using the aluminium extrusions just for keeping some of the structural integrity there. So, but it's still all in the vein of RepRap with all the difficult parts being 3D printed. So, yeah, I think it can be done. None of the things I design, I think about mass production. I think about how I can design them and how I can 3D print them, and don't want to limit myself to thinking about how they'll be mass produced, which I think is I don't have a problem with that, but people take designs and obviously then turn them into parts that they can rapidly produce or make multiple designs of that they can sell. So that's fine.
I think making a really small printer that's completely 100% printable. I shouldn't say 100%, but I mean the mechanical structure.
Yeah.
Are we going this way? That is why I make them small, because I don't like waiting for the long print times. If you can prove them, for a proof of concept, really tiny. I mean, my simple maker's kit's like, 4 inches cubed, and I'd even go smaller if kids would get a kick out of printing them up for their schools.
Yeah, definitely. I think and for a lot of industries and things, small is going to be useful. It's not ideal for FDM technology, but certainly with other types of materials and ceramics and things with very fine nozzles, a small amount of material goes a very long way when you're producing small things. So I think we'll see many more small printers. There'll probably be lots and lots of SLA and DLP type ones, but even on the standard cheap and cheerful RepRap style printers, small is going to be beautiful. And yeah, I mean, my one I specifically wanted something I can take really easily on a train or whatever, and so it's battery powered and all that sort of thing. So it just needs to be able to be quite easy just to set up and press print.
I would consider 100 millimeters on a side the lower limit for the usefulness of the current technology we're using, the RepRap style extrusion based. Certainly for SLA, it's 140 by 150 by 125.
Oh, it's pretty big, yeah. Yeah, I agree.
It's surprisingly big.
Is like, that's cool.
Yeah. And if you can get higher detail, like you can with an SLA or a DLP or something, then certainly you can see there are plenty of designs smaller than that. I've seen some that had a 2-inch maximum in each dimension, but they were super fine detail, like 10 microns per layer max, maybe 5. It's crazy. But for the type of print we're doing, I think 100 millimeters. Yeah. Yes, exactly. But for the type of print we're doing, I think that 100 millimeters is the lower limit for the size you would want to make a machine that is producing this type of detail.
You can always have 2 or 3 or 4.
Yeah, I think that small is great for specifically the RepRap, because to get kids to have something small enough they can sit on their desk, can print the parts to the machine, on the machine, maybe that could take off, because I talk to so many kids, and it's price is the barrier. I say this a lot, but for young kids, price is the barrier. Parents are like, they don't even know what it is. They're saving up their money, you know. But anyway, I'd love to see more RepRaps in school. There was one country, I talked to one distributor in a country, and he said, you'll never get kits, it's like in the Netherlands somewhere, you'll never get kits into classrooms here. They have to be completely polished machines. But in America, I think kits are cool. Or, you know, build your own.
Yeah, I think it depends whether it's going to be useful for kids in the schools. I think the whole process of design, visualization, and then 3D printing something, anything, is a very valuable thing. I think building up printers is probably also quite a useful thing to do for schools. Whether they would want to do that, certainly in the UK here, I think that would be a very difficult thing to implement. I think they would be more interested in the actual finished product and what they could do with it with the kids. But yeah, I hear a lot about people wanting cheap printers, and it does always strike me about what they're trying to do with them. You know, why do you need what are you doing with it that needs to be so cheap? You know, is it just because is this a self-fulfilling thing? Are we just printing trinkets and useless things, and the cheaper we go, the sort of...
I totally get it when people criticize the trinkets and stuff, because I get tired of it too. And it's easy enough to print those things, so I get why they're at shows and stuff. But you know, for a kid that's never seen it or done it, those trinkets do have value, and there's still learning to be had in designing trinkets. So I think schools just see, you know, the more kids that they can put hands on a printer, instead of one, you know, large $3,000 machine or something, having 10 small ones appeals to a teacher, keep the kids busy, and they're all learning at the same time. But yeah, for like industrial stuff now, I get what you're saying.
Sure.
Well, sure, pleasure talking to you guys. I'm gonna let you go.
Okay,
but,
yeah, nice to speak to you.
I'll look forward to I'll sure look forward to participating at another time where I'm not so on the road and sit down and have an actual conversation. It's kind of hard to hear some of those videos and stuff.
Yeah, sorry, I just noticed the message on there to turn my webcam around. I'll try and show you the Mega. It's sat the other way, so just see whether you can see it. So, can you see that?
Oh,
did that come across? It's quite a monster.
Huge. Why do people complain about? I've never built a Delta. Why do people complain that they're hard to calibrate?
I've not really found them particularly hard to calibrate, but they're criticised a lot for all sorts of things. So, but I like them. I think they're good.
I want to build one. I saw, who was it that did the design I want to try is the one that it's really small. I only saw one picture. It might have been Nicholas Seward, but he was reaching over between like he had a bearing on one of the posts, and it actually reached over to a bearing on the other post. So that, I forget the advantage, but it was one I've never seen. That's the one I'm going to try to build. When you have laser cutters, it's so much faster to prototype than you have one, right, Rich? You guys have laser cutters down there?
Yeah, we've got a laser cutter here in the shop. Yes, we have a laser cutter.
Do you find yourself drawn to that, or do you still print a lot of stuff?
I cut a lot of things.
in that now?
Yeah, I mean, some of the stuff we're doing metal for some of our stuff, so the laser cutter makes a better prototype for that. Yeah, it does. It's just faster. If you're making something that's flat, it's faster, and so you end up designing around flat things a lot.
I know, I totally do that. Drives Brian crazy when he has to turn it into an actual like machine part. I only do the flat stuff. I do very little 3D design, to be honest. I do SketchUp, but he doesn't like. He just laughs at me. But yeah, so anyway, I'm going to do a laser cut delta just for fun and see if I like it or not. Do you do deltas, Rich?
I haven't built one. I have a design that I've started working on for one. Just playing around with things. I don't know if I'll ever actually build it.
Yeah.
I got animating in OpenSCAD, so that's pretty fun.
They're just so much fun to watch. I mean, they're mesmerizing. I just love watching them.
Yeah,
I think
they're
some
fun to
people buy them
watch.
just because they're fun.
Yeah, they're definitely fun to watch. And figuring out all the math from scratch in OpenSCAD so that I can animate it was a little tricky. But it was a fun exercise, if nothing else.
Oh, my hat is off. That's over my pay scale, man. That's cool. You'll see it. I don't think I'm going to sell one. I'm just doing it for fun.
Yeah. Yes. Obviously. Obviously, everything I do eventually becomes open source. I've got a backlog right now of stuff I need to post after stopping posting things on Thingiverse.
That is funny. Yeah, I've stopped too. That is funny that some people interpret designers as not sharing them, and the fact is I'm just lazy. Posting all that stuff and getting the files in a format that is presentable and like understandable. It's half of my problem.
Yeah, making the files presentable is a problem. Yeah.
Yeah, I'd agree with that. I've got just so many designs I would like to get out there, but I think last year just posting the 3DR design and the amount of effort that went into making sure that was all done and some documentation things just taught me a lot about how much time and effort that side of things takes, and it's really not interesting once you've moved on to the next thing. So unfortunately the next thing turns out to be 20 things all at the same time, and then it becomes really difficult to just keep posting stuff. But I think that's one of the hardest things about this type of project, that people expect you to post a lot of stuff, and by the time you're ready to post, you've already moved on.
Yeah, I agree. That is one thing that I would totally love help from the community. I dump the whole Dropbox folder on them and say, hey, sit in here and cut all these parts and see which ones work with each other and all that. Just document and publish and take that out of my hair because I don't have time to do it. And if
you get a million questions there. That's the problem.
Yeah, they'd have to be in my shop, man, because I don't even remember answers to all of them. It's like, gosh, just run and gun so much. But there's probably some stuff that people would find useful. Not all of it. All right, guys, I'm seriously going now. I hope you all have a good day. Thanks for the time.
Okay, see you.
All right, take care.
So have we got anything else to discuss, do you think? Any other questions?
We worked through all the questions. So, same thing here. It was nice talking to you guys. Glad you could make it. And we really need to do this another time. We need to repeat this, definitely.
Yeah, sounds good.
Yeah.